Swayam Prabha. Digital India. Educated India.
Welcome back, learners. The video is for the subject of Geography for the course of Bachelor's in Arts with Geography or Bachelor's in Arts with Honours in Geography. The video is for the paper of Climatology. Today in this video lecture, we will be discussing part 2 of lecture 3 on tropical cyclone. The topic of the lecture is tropical cyclones, structure, characteristics and weather conditions. This video is second in sequence for tropical cyclones. So if the learners have not watched part 1 of tropical cyclones, please go back and watch part 1 first and then come back and start from part 2. This will help you better understand the topic. This particular video is recorded by Dr. Pallavi Upreti. The course coordinator and presenter for the video is Dr. Pallavi Upreti, affiliated to Department of Geography, Doon University. The academic expert and reviewer for the video is Professor Santosh Verma, Head of the Department, Department of Geography, SDM Government Degree College, Doiwala, Dehradun, affiliated to Shri Dev Suman, Uttarakhand University. The video is produced and presented under the project name DTH Swayamprabha Channels of MHRD, New Delhi, India. Hello dear learners, I am Dr. Pallavi Upreti, Assistant Professor in the Department of Geography in Dr. Nityanand Himalayan Research and Study Center, Doon University, Dehradun, Uttarakhand. This particular video lecture is second in series for tropical cyclones. We have already discussed various concepts associated with tropical cyclones in the previous video lecture. So please go back and watch part 1 of tropical cyclones and then continue from here. And in this part 2 of tropical cyclones, we will be discussing the structure of tropical cyclones, the stages of development of tropical cyclones, characteristics of tropical cyclones, and what is the global impact of tropical cyclones which is felt in different regions of the world. So let's begin. Before starting the part 2 on tropical cyclones, I would just like to quickly give you a brief of what we did in part 1. In part 1, we discussed in general what are tropical cyclones. We discussed the definition of tropical cyclones. The tropical cyclones are basically low pressure systems. They are violent systems and they primarily develop over the tropical warm ocean waters, specifically in the summer and late summer seasons in both the hemispheres. So their extent is mainly between 30° north to 30° south in both the hemisphere, barring 5 degrees on both the sides of equator where they are rarely found. And we also discussed what are the necessary conditions for the development of tropical cyclones, which included the supply of warm moist air, high sea surface temperature with more than 26 degrees Celsius of temperatures, and then it has to have weak wind shear with developed upper anticyclonic conditions, and tropical cyclones also develop in areas where you have pre-disturbance conditions already existing in the tropical regions of the world. When all the conditions are fulfilled, the tropical cyclones primarily originate over the tropical warm oceanic waters, and they develop due to low pressure when the sea surface temperature over the tropical oceans cross 26 degrees Celsius temperature, and they also derive their energy through the evaporation of water from the ocean surface and finally condenses into huge towering cumulonimbus clouds, which produces heavy rainfall leading to disastrous conditions when they struck the coastal regions. And within the tropical regions, there are 6 major embedded regions which have very high frequency of tropical cyclones. Those regions extends from the western Pacific to eastern Pacific regions. Then you have central and northern Atlantic Ocean, and a very intensive cyclonic activity is also observed in the northern and southern Indian Ocean also. So all the 6 major regions of the world experience these tropical cyclonic activity, which sometimes may develop into severe disastrous natural hazards, inflicting heavy losses to human lives and property, especially along the eastern coastal regions of the continents. So this is all what we discussed in the first part, and it thoroughly discussed the mechanism and formation of tropical cyclones. So from this part 2, we will be starting the structure of tropical cyclones. The main objective of this particular video is to understand the structure of tropical cyclone, general characteristics of tropical cyclone, stages, and in case of tropical cyclonic development, these stages also becomes types. So we will be discussing that also. Weather conditions associated with tropical cyclones and impact of tropical cyclone on our environment, on people in general, and primarily on the tropical regions of the world. So this is the part 2, which we will be just starting now. And all these topics we have covered in part 1, which we have already discussed. So let's begin with the explanation of structure of tropical cyclones. Once the tropical cyclones develop, they have a very distinctive structure which can be segregated into different parts. And it is very different from what we have studied in the temperate cyclones. Temperate cyclones also have a specific structure, but the structure of tropical cyclone is entirely different from the temperate cyclones because the developing and originating mechanism of tropical cyclone is entirely different from the temperate cyclones. So let's see what is the basic structure of tropical cyclone. The wind field of a tropical cyclone may be divided into three prominent regions. The first region is the ring-shaped outer region, which generally extends to about 160 kilometers and have an inner radius of about 30 to 50 kilometers also. The wind speed in this particular outer region of the cyclones uniformly increases as the winds move from the outer regions towards the inner central core region. Then the second region is the eye wall region. This region is the most dangerous and destructive part of the tropical cyclone, which surrounds the central region of low pressure. So as you can see in the diagram, the region which surrounds the inner region of low pressure is called the eye wall. So it kind of forms the wall around the eye, which is the low pressure central core region of the tropical cyclone. It is this region of the tropical cyclone because of which maximum destruction is caused, because the winds which rises in this funnel of cumulonimbus clouds, they condenses and arrange themselves in form of spiral bands around this eye of the tropical cyclones, and strongest wind speed can be seen in this eye wall region of the tropical cyclone, and this wind speed is primarily driven by rapid changes in the pressure gradient force as the wind moves from the outer peripheral region of high pressure towards the low pressure central core region of the cyclone. Heaviest rainfall also occurs when this particular region hits a place due to the presence of rain bands and deep convective clouds rising from close to Earth's surface to almost the height of 15,000 meters above the surface. So because the convection is so intense, the updraft of rising warm air is so intense inside this developed cumulonimbus cloud that the clouds arrange themselves in form of spiral rain bands, as you can see in this particular diagram. And these rain bands are deep convective clouds which are quickly rising up, condensing at a very high speed, because of which these rain bands, they kind of aggregate towards the eye wall, which when hits a particular region leads to torrential rainfall, causing massive flooding in the areas where the precipitation occurs. Now, the third region of the tropical cyclone is the innermost region of the tropical cyclone, which is the eye of the tropical cyclone. And this eye has the lowest pressure in the whole tropical cyclone. And it is the centralmost region also. And in this region, you have clear skies, warm temperatures, and low atmospheric pressure. This particular region of the cyclone is clear from any kind of turbulence, and the wind speed also decreases rapidly, and the air is often calm and very feeble. And additionally, a very weak subsidence of air also is witnessed in this part of the cyclone. But the reasons Why there is a subsidence in this part of the cyclone is still under speculations, and numerous researchers are going on to define the specific reason of this weak subsidence of air in this central region of the cyclone. So as the subsiding air compresses slightly, there is an increase in the temperature in this particular region of the cyclone as compared to the outer eye wall region of the cyclone. So it is a comparatively calmer region of the cyclones with no turbulent formation of clouds, and which is associated with the lowest temperature which is found in the tropical cyclones. Because of this existing low pressure only, the winds are attracted towards this low pressure central core region, and they attain the circular rotating motion, and they start revolving in anti-clockwise direction in the northern hemisphere and clockwise in the southern hemisphere around this low pressure central core region of the cyclone. So these are the three main regions of the cyclone which define its structure. First one is the outer region, second is the eye wall region, and third is the eye of the tropical cyclone. So after going through in detail what is the mechanism of tropical cyclone, what is the structure of tropical cyclone, and what are the necessary conditions for the development of tropical cyclones, the areas where they form, and what are the major regions where they are found around the world, I would just like to quickly give you the general characteristics of tropical cyclones. So it is evident that these are the low pressure systems with more or less circular isoparts, where the winds move from the outer peripheral regions of high pressure toward the low pressure central core region, and they develop mostly over the warm tropical oceans of the world, primarily where the sea surface temperature is more than 26 degrees Celsius. These regions mostly lie between the Tropic of Cancer, that is 23.5 degree north latitude, to Tropic of Capricorn, which is 23.5 degree south latitudes. In general, they extend between 30 degree north to 30 degrees south in the hemispheres. So they are primarily located in the tropical regions of the world, as the name suggests, and their origin is not associated with the development of fronts. So the low pressure center which is created in these tropical cyclones is a non-frontal type of low pressure center, which is primarily developed because of the very intense convection and the rising of warm and moist air to upper regions of the atmosphere, where it condenses, and in the process the low pressure central core is created. Once formed, they vary greatly in shape, size, velocity, and weather conditions. On an average, the diameter ranges between 80 kilometers to 300 kilometers, but in certain cases the diameter may become even smaller than 50 kilometers, and in certain cases it may even extend to 1000 kilometers also. And they also advances with varying wind velocity, wherein weak cyclones move at a speed of somewhere around 32 kilometers per hour, while very violent ones attain the velocity of 80 to 200 kilometers per hour also, and even beyond 200 kilometers per hour at times, when the tropical cyclones is very extensive and destructive. Now, the wind movement is anti-clockwise in the northern hemisphere, and it is clockwise in the southern hemisphere because of the prevalence of Coriolis force. The track and movement and path of these cyclones is also very variable. So although they are found within the intertropical convergence zone of the trade winds, and primarily they are influenced by the trade wind, wherein they are dragged from the eastern parts of the ocean toward the western parts of the oceans under the influence of trade winds. But often they can attain random variable path also, depending upon the intensity of the tropical cyclone and the velocity, the ferocity of wind movement in a tropical cyclone, because of which sometimes they may enter the subtropical high pressure zone also, which leads to their dissipation as they enter the higher latitudinal regions of the world. These systems are more vigorous over sea and they become weak while moving over land. Why? Because they are fed by the warm, moist air which is being constantly supplied by the tropical warm oceans of higher sea surface temperature. But as soon as they hit the land, the supply of warm, moist air is cut off, which ultimately leads to the decay of tropical cyclone after reaching continental interiors. Hence, the impact is mostly seen in the coastal areas where they may develop into severe disastrous natural hazards, causing heavy loss and damages to human lives and property because of immense torrential rainfall and flooding along the coastal regions. And they also may become stationary at times, yielding heavy precipitation, causing floods and environmental disaster. So, although the tropical cyclones move at a higher pace, but sometimes, due to certain specific conditions, they may also become stationary, yielding heavy precipitation, leading to massive inundation, flooding, and environmental disaster, which is inflicted by very high wind speed movement along with storm surge. We will be just studying all these things in the coming slides. Their development is confined to a particular period of year, especially during the summer season, mostly late summer season, primarily because of the properties of water which take more time to get heated. And as water takes far more energy to heat up and is finally warmed enough till the late summer time period only, which triggers the level of evaporation required for the tropical cyclones to develop. So this applies to both the hemisphere. Whichever hemisphere is having summertime period, the conditions for the development of tropical cyclones becomes immensely favorable, with the sea surface temperature exceeding 26 degrees Celsius and more in both the hemispheres. The frequency and affected areas of tropical cyclones are far less than temperate cyclones, since the occurrence of tropical cyclones are rhythmic in nature because they are restricted to certain seasons of a year, which varies from one region to another region. So the frequency is heavily dependent upon the summertime period. Therefore, their frequency is comparatively lesser than the temperate cyclones, the formation of which totally depends upon the frontal conditions and collision of air masses of varying character across that front. So wherever that frontal regions are created in the temperate regions of the world, it can lead to the development of temperate cyclones. But in case of tropical cyclones, their activity, their frequency, their intensity is totally restricted to a specific time period of the year, which is summer season. Then another characteristics of the tropical cyclone is that they are one of the most violent and disastrous natural hazard systems, which can even exceed to 400 kilometers per hour of speed, leading to torrential rainfall, very high tidal surge, which can totally destroy a coastal region, and it can take several days to weeks to finally dissipate, and in that particular time period it inflicts massive damage of life and property, especially along the eastern coastal margins in the tropical belts of the world. Now, in order to discuss the stages of the tropical cyclones, it is important to note that since tropical cyclone has to pass through various stages to finally develop into an extensive tropical cyclone system, these tropical cyclone stages only are sometimes also known as the types of tropical cyclones, also because each stage has a distinctive characteristics, wind movement, and weather conditions which are associated with the specific stage. And it is not necessary also for the tropical cyclones to evolve into an extensive system of hurricane or cyclone. Sometimes the tropical cyclone may remain a small disturbance and may totally die off. So the stages and types of tropical cyclones are mostly used synonymous to each other. All the weather systems, tropical cyclone produces some of the most intense and damaging weather conditions. But they are so varied that the characteristics of no two cyclones are identical. Hence, the classification of tropical cyclones becomes very difficult. But tropical cyclones generally develop from a small disturbance and over the time period may grow into a very intense tropical cyclonic system. Based on that, the tropical cyclones are generally divided into four common types based on their intensity. These types are also defined as the stages of formation of extensive tropical cyclone also. So once the extensive tropical cyclones fully develops into a hurricane or a typhoon or a cyclone, all the lower stages of that developing tropical cyclones can also be defined as different types of that tropical cyclones, because in each stage the intensity, wind movement, the precipitation totally varies from one tropical cyclone to another. So let's see what are those stages or types of tropical cyclone. Tropical disturbance or easterly wave stage is one of the smallest stage of the tropical cyclone. A tropical cyclone does not develop instantaneously, and some intermediate weaker disturbance is needed to provide the seed from which the tropical cyclone evolved. So formation of an asymmetrical, unorganized, incipient disturbance existing in the tropical warm waters is basically the seed to loosely organize the cumulonimbus clouds, and the disturbance begins to show signs of weak circulation with low wind velocity. And this type of weak wind circulation is called as tropical disturbance. So the intensity of wind movement is very low. They are not even properly organized in this type of cyclone. So this is the smallest stage of the tropical cyclone also, and it is one of the type of tropical cyclones also. From here, the tropical cyclone grows and enters into another stage of development. Now, once the movement of winds gains some speed, and once the speed reaches to 36 kilometers per hour or more, the storm is classified as tropical depression. So it has moved over the category of tropical disturbance and it is entered into a category of tropical depression now, where the wind speed has increased. But it is still a small center of low pressure and develops around the vicinity of intertropical convergence zone. So a low pressure system is slowly, gradually coming together with medium wind speed. Then this tropical depression grows into a tropical storm. So if all the factors support, the circulation continues to intensify and the wind speed exceeds 63 kilometers per hour. And then the tropical depression is categorized as tropical storm. So you have to understand that at each stage, the tropical cyclone may die off also completely dissipating. So through all these progressionary stages of tropical cyclone, you can see that how a big hurricane type of tropical cyclone evolved from a mere small tropical disturbance. So in this tropical storm, a well-defined low pressure center is developed which intensifies and the isobars becomes packed up. So isobars starts coming together because there is a sudden fall of the air pressure which leads to packing of isobars towards the low pressure center, which leads to heavy rainfall, and it may also lead to coastal inundation if it hits a coastal area along the tropical regions of the world. So after this tropical storm continues to grow, it attains extensive characteristics and develop into tropical cyclones. At this time, the wind speed crosses 100 kilometers per hour of mark, and the storm is classified as extensive tropical cyclones. And these extensive cyclones with very high wind speeds are known by different names in different regions of the world. Like they are known by the name of hurricane, US and the Pacific region. They are known by the name of cyclones in Indian Ocean, and they are known by the name of typhoons in China and willy-willies in Australia and many other regional names. So Once this tropical storm attains the maximum wind speed, which exceeds more than 100 kilometers per hour, the storm is classified as extensive tropical cyclone. And in these conditions, the diameter also becomes very extensive, which may range from 160 kilometers to even 640 kilometers. And in these conditions, they develop very close, most symmetrical isobaric structure because of the drastically increasing pressure outward from the intensely developed low pressure region at the center. As the pressure falls drastically when one moves from the high pressure outer region towards the central region, there is a drastic decrease in pressure, because of which the winds also attain very high speed when they swirl around this center or low pressure. And in the process, since the wind moves in a very high speed, there is sudden condensation which is taking place inside the developed cumulonimbus clouds, and this leads to quick condensation of the rising warm air from the surface, which leads to the formation of deep convective cells which are arranged from the eye wall towards the outer peripheral regions. And these deep convective cells carry tremendous amount of condensed water vapor, which when hit any region causes heavy downpour leading to massive inundation and flooding. So tropical cyclones are actually the terminal stage of the cyclonic activity in the tropical regions of the world, which start from mere disturbance, then grows to a depression, then elevates to storm if all the factors support, and finally grows into a very destructive and damaging weather system which is called as a tropical cyclones. And sometimes when the raging speed exceeds more than 200 to 400 kilometers, also they are classified as category 5 tropical cyclones, which are deadliest and the most destructive of all, causing widespread massive damage, especially along the coastal areas in the eastern margins of the continents in the tropical belt. So this diagram clearly shows all the stages of intensification of a mature tropical cyclone, where you can see that initially it is just a small tropical disturbance which grows in the intertropical convergence zone of the lower latitudes, and it is just 1 to 5 days old, and the wind speed and intensification of wind is also absent in this kind of tropical disturbance. But if all the conditions support the development of tropical disturbance, it grows to a tropical depression. Now you can see that the winds have started gaining the circular motion. They are more organized now in this tropical depression, and the depression is 5 to 6 days old. Further, the tropical depression grows into a proper spiral movement of winds, where you can see that the winds are gushing towards the well-developed low-pressure central core region. And here the wind speed has exceeded to somewhere 63 kilometers per hour, and this is categorized as tropical storms. So when these tropical storms strike coastal areas of the continent, they lead to massive damages of life and property in these coastal areas by causing heavy precipitation. But if the storm does not die here and it further intensifies, it leads to the formation of the most extensive cyclones, which are called as hurricanes or cyclones or typhoons. So this is the region of USA. So in this belt, the extensively developed cyclones with very high wind speed exceeding 100 kilometers per hour, they are called as hurricanes. And when these hurricanes with very high intensity wind speed strike the coastal regions, they cause massive damage in these regions of the world. They completely destroy the buildings, vegetation, transportation system, the power supply systems, and everything which comes into their path. But as soon as they hit the land area and tries to move inside the continental areas, the supply is cut off, which leads to the decay of tropical cyclones. But if the tropical cyclones by any chance is so extensive that it can even sustain and move beyond the tropical regions of the world, they undergo extratropical transitions, wherein they then feed the extratropical cyclones of the world in the temperate belt. At last, after passing through all these stages, the cyclone either decays after hitting the land or after reaching the higher latitudes. The ocean surface is not able to maintain the 26 degrees Celsius temperature to sustain the tropical cyclones, or there can be sudden descent of air from the upper atmosphere which kills the existing low pressure center, which kills the cyclone, or it may go under extratropical transition. But this condition happens to only very extensively develop cyclones which can sustain when they cross and move beyond the subtropical high pressure belts of the world towards the temperate regions of the world. So when they cross over this, they undergo transition, and here they feed the formation of temperate cyclones. So you can see that various stages of tropical cyclone intensification are very unique, with specific wind systems, specific precipitation system, movement of winds, patterns of wind movement. These stages of tropical storm development are also considered as specific types of cyclones also. This was all about the stages and types of tropical cyclone. Now, coming to the weather conditions which are associated with tropical cyclones, we have already understood that tropical cyclones are rotating wind systems which move from one region to another, causing massive damages when they strike the land. And weather conditions drastically vary in tropical cyclones, which can be divided into various sectors. So with the progression of tropical cyclone, you have varying weather conditions. So this is called as the front region of the tropical cyclone, and this is called as the eye of tropical cyclone, and this is called as the rear end of the tropical cyclones. So as the tropical cyclone moves into a specific region, what you first see, what weather conditions you first witness is actually the part of the first sector, which is the arrival of the tropical cyclone. So as soon as the tropical cyclone arrives, the arrival of tropical cyclone at a particular place is heralded by sudden increase in air temperature with increased wind velocity, and this wind velocity also leads to sudden increase in air temperature with marked decrease in air pressure. So suddenly, if a place is witnessing the coming of tropical cyclone, the temperature increases. So when the air temperature increases, there is decrease in air pressure also. And appearance of cirrus clouds or cirrostratus clouds first develop before the development of thick cumulonimbus clouds, and the cyclone progresses towards a particular area. Visibility becomes obstructed since the sky is overcasted with thick dark thunder clouds, which leads to heavy precipitation in form of rain, and this rain is experienced mostly in the coastal regions of the world which are struck by the tropical cyclones moving westward. These type of heavy showers are also associated and followed by thunder and lightning, and then the tropical cyclones become extensive, and this also leads to the emergence of high waves in the coastal areas, which sometimes inundates the coastal floodplains and coastal residential areas also, which is called as storm surge. So because of the intense cyclonic activity, the entire sea level near the coastal areas inundates the coastal areas, leading to massive damage along the coastal areas. High waves start emerging in the ocean. These conditions persist for few hours, and then the eye of the cyclone arrives. So these are the conditions before the arrival of the eye of the cyclone. So when any region of the world is struck by the cyclone, actually the half front part of the cyclone strikes first, and these conditions persist for few hours, and then the eye of the cyclone arrives over that area. Now, with the arrival of the eye of the cyclone, there exists cool and calm condition. The arrival of the center of the cyclone is characterized by the calm breezes, clear sky, rainless, brighter weather. So now this half part has actually gone. So the regions which are located beyond this eye on the surface of Earth are actually witnessing the clear, rainless, brighter weather because of the arrival of this eye, which is a very, very calm and cool region of the cyclone. But only half cyclone has entered the territory now. And at this point, you have very low pressure at the center, and such weather stays for some time and suddenly changes with the arrival of rear portion of the cyclone. So the half cyclone is yet to come from behind with all the heavy precipitation, towering cumulonimbus clouds, torrential rainfall. So the weather conditions associated with tropical cyclones are actually witnessed in sectors where first you witness the front portion of the cyclone with heavy precipitation, torrential rainfall, coastal surges, and then when the eye of the cyclone arrives, you actually witness the calmness of weather with clear sky, calm breeze, low pressure at the center, which is again followed by a very intense weather when the entire cyclone passed over a particular area. So now the third stage is actually the arrival of the rear portion of the cyclone, which is this back portion of the cyclone. Sky becomes cloudy again and wind direction changes dramatically. Wind speed increases suddenly as the pressure sharply decreases again. Warm air lifting from the base gushes to the center of low pressure, and very, very thick cumulonimbus clouds are formed due to sudden lifting of air, which leads to immense condensation of water vapor in a very, very short time period, leading to heavy downpours with clouds thundering and lightning, and storm becomes very severe and furious. As you can see in this diagram, that as the eye of the cyclone passes and the back rear portion of the cyclone emerges, there is sudden drastic changes in the wind and weather conditions. Storms surge with massive coastal inundation and flooding takes place because very high tides are dragged towards the coastal lands, and these conditions exist for hours, and sometimes these storms may also become stationary, leading to heavy downpours for days, and then it may clear out gradually on further moving inside the continent because the supply of warm air from below as it moves inside the continent is cut off. So even it has remained stationary over these coastal areas and gradually move inside the continent, the moisture supply is cut off, which leads to decay and dissipation of the cyclone. So these are the weather conditions which a particular place on Earth faces with the arrival of the cyclone. Now, tropical cyclones are considered to be one of the most violent systems of the world because they cause widespread damage. And tropical cyclones, normally between 100 to 2000 kilometers in diameter, are one of the most destructive natural hazards impacting various regions of the globe, including Gulf Coast of North America, Australia, Indian Ocean, Bangladesh, and various other Asian and African countries in the world. Over the past 50 years, 1942 disasters have been attributed to tropical cyclones, which killed more than 7 lakh people, causing damages worth more than 1400 billions. In terms of economic losses, an average of 43 deaths occurred due to the occurrence of tropical cyclones, and 78 millions in damages on an average are being lost due to the tropical cyclonic activity. So why these tropical cyclones are so destructive? What is the reason that these tropical cyclones are so destructive? They are mainly destructive because of the existence of very high intensity wind movement, and high winds cause some of the most dramatic and damaging effects associated with tropical cyclones. So the most intense tropical cyclones may even sustain wind speed of somewhere around 240 kilometers per hour, and it can also exceed to 320 kilometers per hour, which can cause massive damage in the areas where they enter, where they are experienced. And this high wind shear and downburst may also lead to tornado conditions sometimes when they enter inside the continental areas. Besides the high intensity wind, the rainfall is another very important destructive factors which makes the tropical cyclones so damaging. The tropical cyclones typically bring large amount of water, causes massive torrential rainfall, and much of the water is due to the rainfall which is associated with the deep convection and formation of rain bands in the tropical cyclones around the eye wall. And these tropical cyclones, when they move towards the coastal areas, these deep convective cell causes immense precipitation, leading to inundation and flooding in the areas where such high rainfall takes place. Now, besides high intensity rainfall, you also have storm surges. So in coastal areas, an elevation of sea level called as storm surge is often the deadliest phenomenon which is associated with tropical cyclone. And a storm surge which is accompanied by very intense tropical cyclone can be as high as 6 meters or 20 feet, and most of the storm surge is primarily caused by friction between the strong winds in the storm's eye wall and the ocean surface, which piles up the water in the direction that the wind is blowing, leading to massive coastal inundation, coastal flooding. And this flooding, because of the storm surge, is responsible for most of the deaths which are associated with tropical cyclone landfalls worldwide. Besides the storm surge, the gust, downburst, and swirls also cause massive destruction when the cyclone makes the landfall. Because of the sudden decrease in the friction of the wind speed as it strikes the continental barrier, it leads to the increase in the turbulence, and this allows the fast moving air aloft to be transported down to the surface suddenly, thereby increasing the wind gust, which may also lead to sudden microburst and macroburst and very intense precipitation along these areas, which causes massive damages in the coastal regions where you experience landfall. So the impact of tropical cyclones is very immense, and this impact is further inflicted if the tropical cyclone hits any economically backward regions of the world, because those regions are very vulnerable and they don't have much of the resources and capital to face the damage which is inflicted by the tropical cyclones, which increases the death toll, hunger, and even the environmental damages to a greater extent in the low developing regions of the world. So above all these conditions, the economic condition of a particular country also helps in tackling with the damages which are inflicted by tropical cyclones. Some of the deadliest cyclones which we have witnessed in the recent past, among which Hurricane Katrina is one of the deadliest and the most powerful cyclone, which is a category 5 cyclone, that is the wind speed exceeding more than 200 kilometers per hour. And this tropical cyclone struck southern USA on August 28, 2005 with wind speed more than 257 kilometers per hour. It remains as the costliest hurricane in the US history, causing an estimated damages of $161 billion, and it destroyed more than 850,000 homes in the southern region where it took the landfall. The flood caused by the hurricane inundated and buried up to 80% of New Orleans, which is located in southern USA. So actually you can see in this diagram that nearly 80% area of New Orleans was completely inundated by this Hurricane Katrina. Besides Hurricane Katrina, you had Hurricane Sally, which was a destructive and slow-moving Category 2 hurricane in the Atlantic Ocean, which struck USA state of Alabama in September 2020, causing massive damages estimated at 7.3 billion USD. Although it was a slow-moving hurricane, it completely inundated various states of USA with maximum damages on Alabama state. There was massive coastal surge, coastal inundation, and flooding in the coastal areas, completely drowning the southern settled regions of the Alabama state along the coastal belt. Just observe the formation of deep cumulonimbus clouds and the movement of wind along this centrally developed low core region of Hurricane Sally. Also observe that as the hurricane moves inside the continental areas, the supply of warm air from the Atlantic Ocean is totally cut off, which is gradually leading to its dissipation after the landfall. So these major areas of the Alabama state, especially located along the coastal belt, were completely inundated because of the heavy precipitation and coastal surge. So there was immense damage of life, property, and environment because of this massive hurricane which took the landfall in the southern state of Alabama. Now, besides the Atlantic Ocean, the Indian Ocean is also very active in the frequency of the tropical cyclones. So, in the Indian Ocean, there are two major areas where you experience the tropical cyclones. You have the Arabian Sea region, and then you have the Bay of Bengal region. And in both these regions of the North Indian Ocean, you experience the tropical cyclonic activity in different time periods of the year. So in Indian Ocean, you have basically two peaks for tropical cyclones activity. One is the tropical cyclonic activity in the Bay of Bengal region is mostly experienced from September to December. So this is the first peak season where you experience the cyclones, and another peak time period is between April to June. Looking at the graph also, you can see that the frequency of the tropical cyclones is maximum in the month of May, where you have more than 16 tropical cyclones which are experienced in this region during this time period. And then another peak time period is around October, where you have massively developing tropical cyclones which hit these areas. So it is important to note here that this belt is located in the intertropical convergence zone, because of which most of the cyclones which develop in these regions are actually dragged westward under the influence of trade winds. So all these eastern part of the Indian subcontinent along the coast of West Bengal, Odisha, Andhra Pradesh, Tamil Nadu, and then you have Bangladesh also. So all these regions massively experience the tropical cyclonic activity, where most of the tropical cyclones take their landfall in the eastern coastal margins of the Indian subcontinent. Besides this, the tropical cyclones developing in the Arabian Sea region, they also migrate and hit the southern parts of the Central Asian region. Besides this, the South Indian Ocean is also a very active zone around Madagascar and around the eastern part of the African continent. There also you have massive tropical cyclonic activities which are witnessed in specific summertime periods of the year. North and South Indian Oceans are also very active in terms of tropical cyclones. One of the recent most disastrous super cyclone that struck the eastern coast of Indian subcontinent was the super cyclone storm Ampan, and it was a very powerful and catastrophic tropical cyclone that caused massive widespread damage in eastern India, specifically in the West Bengal and Odisha region, and it hit the area on May 2020. So you can see in this small inset the path of the landfall of the storm Ampan is clearly shown, and you can see that it caused massive coastal surge and inundation along the eastern coastal region of India, and also caused massive damage in Bangladesh. So this is the movement of the tropical cyclone. You can clearly see that since it is located in the northern hemisphere, the movement of wind is anti-clockwise, and while having the anti-clockwise wind movement, it constantly progressed and hit the coastal regions of India and Bangladesh. And it was the costliest cyclone in terms of recorded damages so far, worth 13.2 billion, with widespread destruction of life and property in India and Bangladesh. So coastal inundation, destruction of houses, complete destruction of agriculture crops, and the forest regions of Bangladesh and India was very massive in these regions. So you can see that cyclone Ampan in recent past is one of the most destructive tropical cyclone which India has seen. So summarizing the video now, tropical cyclones are centers of low pressure which develops over tropical warm waters. The structure of tropical cyclones include ring-shaped outer structure, then you have the eye wall and central region which is the eye. So you have the central region of low pressure which is the eye, and then you have a wall surrounding this eye which is called as eye wall, and then you have the outer structure which is called as the ring-shaped outer structure, where you have the spiral arrangement of rain bands and heavy rain-bearing clouds. The development of tropical cyclone passes through sequence of stages as it intensified into mature tropical cyclone. So you have the weakest one, which is tropical disturbance, and then it intensified into tropical depression, where the wind speed increases, and finally when the wind speed is somewhere around 63 kilometers per hour, it becomes tropical storm, which is also comparatively very destructive. And finally it intensified into big extensive cyclone which is called as tropical cyclone with more than 100 kilometers per hour of speed. And sometimes these cyclones may also intensify further and develop into very destructive systems like hurricanes, cyclones, typhoons, and willies. So well-developed tropical cyclone is known by different names across the tropical latitudes. They can be called as hurricanes in USA and Pacific, then cyclones in Indian Ocean and Indian subcontinent, typhoons in China, and then willies in Australia. However, although they gradually dissipate once they hit the land because the moisture source is completely cut off, but they are strongest over the ocean where they are constantly fed by the warm rising supply of air. Besides this, when they hit the land, they cause massive coastal damages along the eastern margins, primarily because of the very high wind speed, high intensity of precipitation, followed by coastal surges, followed by macroburst, microburst, thunder, and lightning. So each year during summer seasons, they inflict massive damage on property and loss of human lives when they strike the land area along the eastern margins located in the tropical areas of the world. So tropical cyclones are very intense weather systems. They are very severe, disastrous natural hazards which may impact economy, environment, climate, people in the tropical latitudes of the world. And the vulnerability of the communities which are hit by the tropical cyclones exceeds if they hit the developing regions of the world which have limited resources to rebuild their life, social and economic systems. So with this we have completed very important topic of module 6, which is tropical cyclones. I hope the video was informative. Thank you so much.